Hi everyone, welcome back to the Automotive Logistics and Supply Chain Red Sofa. Very pleased to be joined by Jean-Marc Carlicchi, who leads supply chain engineering for Renault Group. And we've just been on a session talking about being lean and resilient at the same time, about visibility and dynamic planning. And one of the things you raised, Jean-Marc, and what we've spoken about before is the development of operational control towers for Renault, both inbound and outbound. Can you tell us a little bit more about the information and data layers that you've integrated into both of these operational control towers?
Yeah, thank you very much for having me. And we'll kick off with this question. It's the operational control towers. We started with the inbound. Historically, the OEMs they are much better at inbound than outbound, and then we started with the inbound, and which was like 3.5 years back, and now 1.5 years back we started the outbound. So both of them are now operational. The inbound control tower, you have a lot of data, a lot of information. Basically, imagine a big flat screen with a map, and you know exactly where your parts are in which truck, and if this part is reaching on time or not the plant that is supposed to go, and then the AI is telling you it's going to be late, so please, you have this option, it will cost you that, and then the operator can save time and then just choose one of the options. So that's for the inbound control tower. So a lot of data, cost, geographical data, a lot of tracking, as you know. And the outbound control tower, the little sister of the first one, is exactly the same concept. So same big screen, same map, but instead of looking at a line stop risk, you're looking at a customer delay risk.
So there we have a very good, strong integrated view. But what you've talked about, the next step is to move towards an engineering control tower and a more dynamic planning. Tell us more about what this entails and what is happening to build this.
Yeah. So the big difference between the two is about the data, because it's not really the same data, and especially not the same amount of data. In an operational control tower, you have the amount of data, you have your network that is designed as a given, maybe one or two backup options. If you do an engineering control tower, you need to have the full potential of the changes that you can do. For example, the center can be there, but there and there and there, and it multiplies the data you need to input in your control tower. So that's one of the main difference about the data. It's the quantity of data you need to have. And this data, you need to get it either from the RFQs that you are doing and your knowledge of the market, or you can go to a digital player that is already in the place, but it's quite new now in the outbound. So we don't have that, and we have to make our own to start with. And the second impact on the data and the difference between engineering control tower and operational control tower is the layers and the set of data that you need to have, the type of data. For the engineering control tower, you need to have contractual data, which is a big difference. You don't need only standard one like one price, one capacity, one lead time. No, you need to have, if I have this capacity and if I want to go above this capacity, I need to have a different price. Maybe a third price, because sometimes there is a double layer of it and the systems are not designed for it. And it's, again, a lot of data, but different set of data, the flexibility of what our LSP can provide to us. So very challenging to set up those control towers.
Absolutely. And one of the things we talk about coming from this is with this information and contracts and engineering, marrying this, you would see the changes happening in real time and the need to optimize in almost real time, or let's say very, very frequently. What impact does that have on how you contract then with logistics partners? Can they move at that rate of change and pace?
Today, definitely no.
Yeah.
Nobody can move it. Us. We don't know how to move at that pace, but this is where we want to go. So the first step will be to revise and to say, okay, guys, what is acceptable to change and at what pace?
Yes.
Today, our RFQ are between 6 months to 3 years.
Yeah.
Okay, so the longest been 3 years. If we change something, 6 months after the start of RFQ, we still have 2.5 years to wait.
Yeah.
We cannot wait that long. And we need to be very clear with the guys, contractually, what is a change, big change enough to change the RFQ before the end of the RFQ? And is it acceptable for you guys? And all this discussion should happen before making the RFQ. And this is a big change.
Absolutely.
And this is for the next step.
It's an important change point. When you're looking at, you talk about AI being integrated into these control towers. Can you give us an example of how it's being used and how it's being used to shape and influence decisions?
Okay, so this is a little bit what I was explaining. So I go in more detail. So you have one flow engineer that is looking at at a particular flow, and he sees a red alert on one truck. So he goes into this truck, look at the parts number. Maybe you have 20 parts number in this truck with different quantities, and one of them only is red because it will reach late as an ETA to the plant it's supposed to be delivered to. And there, when you click on that, you can have options, and this is where the AI kicks in. You have some option, and the AI is telling you, okay, I have learned in the past year because we put the AA behind the guys that were doing the job, and the AA learned how to react and propose solution number one. In 96% of the cases, the guys, they have been doing that, so maybe that's a good idea.
Yeah.
And the AA is going in the good database to find the cost, additional cost or additional lead time, and it saves a lot of time to the operational guys to work on more added value.
Absolutely. Finally, Jean-Marc, last question. With this enhanced information and this integration of technology, is supply chain taking a larger role in influencing and driving long-term decisions, strategic decisions on manufacturing, procurement, product, etc.?
Yes, I would tend to say yes to your question, but let's be humble there. Yeah, we have to have a lot of humility. Historically, the supply chain is a 3 months to 6 months in automotive. Now we have gained a recognition almost about 18 months in the time span, and supply chain has become a kind of referee, speaking with data between sales and marketing, manufacturing, finance, quality. Then we have gained some influence, some importance, but for the very long term now, we need to prove again ourselves on a much larger span time than 18 months. We need to go to 3 years, and that's a more tricky thing to do. Yeah.
Well, Jean-Marc, this has been, again, this journey here with these control towers, and this planning is very dynamic. We're very excited to have shared it with our audience. Thank you so much for sharing your views, and we'll continue to have more on automotive logistics media, on Jean-Marc's presentation, and more on digitalization across the sector. So thanks so much for sharing with us.
Thank you very much, Chris. Thank you.